So to start with, we're gonna go over the quiz. This is a quiz. I think it's pretty straightforward, but gonna go over it anyway. So the first thing we're gonna talk about is unsigned types. So the way that you'll see unsigned used in code is, whoopsie, is something like this. So unsigned int, let's say number, right? What unsigned means is it moves the range. So for example, for a normal int, we have a regular range of, let's say like about -2 billion to 2 billion. The only thing unsigned does is it moves the range starting at 0 being the smallest one, so it's only positive numbers, and then we get about 4 billion, right? If you set an unsigned type to a negative value, what happens? So like, let's say if we have -5, right? Then instead of negating -5, we'll get 4 billion, 4 billion, right? Minus -5, which is a massive number. And this can cause a lot of problems and a lot of bugs, right? So when would you want an unsigned type? There's a lot of situations, but it's basically just when you don't want things to be negative. So an obvious example is something like a for loop, right? It's just great to have this. Ooh, I spelled unsigned wrong. Is to have like this be unsigned because it should never be negative. There's no reason for it to ever be negative, essentially. So you might have something that looks like this, right? And then it's very convenient because it also allows us to have like a bigger range. Okay, so variable initialization. What are the default values for variables? One of the quirks of C++ is it doesn't really have any. So for example, the example they give is int x. This doesn't really have a default value. It can be pretty much anything, which is kind of annoying because it also means if we were to like, I don't know, x plus plus, this might cause some problems. It might cause some errors. A lot of behavior we don't really want to do. So what value should you use for initialization? I mean, there's some obvious ones like x is zero. I mean, it always depends on the context that you're doing it, but generally speaking, things like 0 or like numbers that you're expecting are the best way to go about it, right? Input and output. So what are the input and output stream objects? They're both part of std. One of them is called cin for input, and the other one is called cout for output. And then you'll use this or this if you want to store variables onto it, right? So what are the 3 building stages of C++ application? Generally speaking, they go preprocessor. I'm actually going to write. I'm just going to write PP for preprocessor. Then it goes linker, and then it goes compiler, right? So they all do very different things. So for example, the preprocessor does all the preprocessor directives. You might have already seen some of them. Things like pound include. Let's say IOStream is a very popular library. Maybe if you're including your own library, you might do, I don't know, file.h. And what it does is it grabs all of these and pastes things accordingly. Right, these are all the 3 different parts. Okay, declaration versus definition. What is the purpose of a prototype? So a prototype will look something like this. It just essentially doesn't have any code in it. So for example, we might have a void function. Let's say we have int a. This is a prototype because there isn't any code associated with it. It's just a function. It's just the name of the function essentially and the parameters. So what the definition is if we have something like this, right? Void function int a, but we have, let's say, some code here that's like, oh, cout hello world, right? This is a function definition because there's braces and there's code that is associated with that function. And I believe that answers both of these questions. It's different because there's code, basically. Errors and warnings. When given multiple errors after building a program, which error should look at first? You should always look at the top error. So you might get things like, oh, error 1, missing semicolon or something like that, right? Or missing semicolon. Error 2, function does not exist. Something like that, right? You might have a bunch of errors, 3, 4, etc. You're gonna have a ton. But the only error you should look at is error 1 because a lot of these errors aren't necessarily true errors. They're just all being caused because of error 1. So generally speaking, ignore everything that's not error 1. And then if after error 1 it still happens, then it will be your top error and then you can deal with it first. Will warnings affect your code, whether your code compiles? No. One warning that you'll probably see a ton, especially depending on how you're writing your code, is unsigned versus signed. So if, for example, you do something like this, right? You say, here, I'll actually write a quick example. Actually, I have one up here. Let's grab this example. And let's say we make a variable in here. It's called int j is equal to 0. If we have an if statement and we say I equals j, if we do this, this will actually give us a warning because we're comparing an int to an unsigned int, which is allowed, but as the next question points out, will warnings affect your program after it runs? This will compile, but you might have some bugs depending on the situation, right? Because if j happens to be negative and I happens to be positive, we're going to get what's called undefined behavior, and we don't really want to deal with things like that. So generally speaking, you should deal with warnings, but your program can compile without them. So as the last question, should warnings be ignored? They shouldn't, because you can cause bugs, and you don't want bugs in your program. You want to write good code. That's kind of the goal. And I think this is pretty much it for the study guide. Fairly straightforward. If you have any questions, just like email me or whatever.